Let's start on the field of surface hardness. Nitriding giving us the surface hardness level starting from 900 up to 1200 vickers. How it looks on carburizing field?
Yeah, it depends. It depends the same like in the nitriding as well. So, because when we think about the nitriding, indeed, in my opinion, it started not only for 9. You said 900. No, this is not the lower level. For me, even 500. That's the first point. It depends on the chemical composition of each material. But anyway, in our business, when we think about hardness and when we think about the technology, carburizing, nitriding, it's always, we say always, it's hard. Yeah? We know that nitriding is much higher hardness on the surface, but let me raise one point. It's really hard when we measure it by Vickers scale. Yeah, of course, in Vickers scales after carburizing, this hardness will be lower as well. But anyway, during or after carburizing, we can measure. We always, or almost always, we measure it by Rockwell scale. Yeah, and we talk about 60 plus several Rockwell scale.
We have to remember that the surface hardness is thick on nitriding side. Nevertheless, we can assume that it is usually much higher comparing to the carburizing. Of course, the case depth is not so big comparing to carburizing, but it's still the surface hardness is higher.
Yeah, it's higher. It's definitely higher. So it's the end of story about the value. Yeah, but anyway, when we once again when we think about the hardness up to starting from the surface and going into the core, it's dramatically, let's say, this word dropped. Yeah, until the core hardness, which in many solutions or many materials landed even 200. Yeah. So the difference between the core hardness and the surface hardness in the nitriding is really huge, and of course it has some benefits as well in many applications. But on the other side, when we think about the carburizing, the difference between core hardness and surface hardness is much lower. That's the differences in those two technologies. Yeah?
I would say that's the good summary for this point.
Okay, we've already talked about the surface hardness, but Jędrzej, make me aware more about thickness layer. Say something.
Well, as you mentioned before, the nitriding layer is rather thick. We are talking about the layers in the range of 0.05, maybe up to 0.8 with the very long nitriding processes. Okay. How you can compare it with the nitriding?
So many times we started from 0.9, maybe 0.8 actually, but anyway, the shortest carburizing layers actually could start 0.2 and finally end even to 8 millimeters.
So we can say that when nitriding is finished, the carburizing is starting.
Good point, but from the other side, even 2 millimeters of carburizing layer could happen faster than the nitriding 0.2 thick layer. So summarizing the thickness layer, in my opinion, I think you will agree with me, during nitriding you never achieve the case layer as for carburizing you can achieve.
For sure.
How about process time, Jędrzej?
Well, that's the good question. I heard it many times from my partners, and looking at the nitriding, when we would like to achieve the case depth around 0.2, it will take more or less 18 hours.
Mm-hmm. Oh, it's really long time. So when we talk about the 0.2 for carburizing, I think it's the maximum 4, maybe 5 hours. So please explain why in nitriding we need so long time.
Main purpose of it is the time of the diffusion in the particular
speed of diffusion as well.
Yeah, speed of the diffusion in the particular temperature. It seems that there's no reason to compare carburizing and nitriding as itself, and we should analyze the whole process, including all phases before and after the heat treatment.
Yeah,
so
definitely.
Let's leave it for now. What about ecology?
Ecology, yeah, ecology, good point to discuss. Carburizing, it seems to be really easy to explain. Low pressure carburizing follows to the ecological way. When we compare traditional carburizing with low pressure carburizing, we can see absolutely the trend from the point of ecological. Did you know that 25 cubic meters per hour of endo atmosphere produce 10 kilogram per hour of CO2? It's roughly about 80 tons of CO2.
We have the same trend in the nitriding. As a good example, we can take zero flow technology, which also reduce the emissions even up to 8 times comparing to the traditional two-gas nitriding.
Yeah, zero means zero. Yeah?
Michał, let's talk a little bit about the distortions.
Wow, distortions. Distortion is a hard subject for low pressure carburizing or even hardening itself. So distortion always occurred after carburizing, low pressure carburizing. We can only minimize these aspects using different quenching media. The best is the high pressure gas quenching.
Nevertheless, we cannot avoid it. And
Never.
I would say that this is the point in favor for the nitriding, because of nitriding is practically free of distortion.
Let's talk about the mechanical properties. Jędrzej, shortly, 3 the best for nitriding.
Fatigue and tribological properties and corrosion resistance.
Okay, for carburizing, we have a good balance between surface hardness and core hardness. That's the first one. Then the impact strength and resistance for pressure on the surface. So
we talk about the features, about the advantages of both these technologies, and I think as a summarize we can say that they are different, and the results of the heat treatment are completely different. Michał, do you see any common field for these technologies?
Both technology are totally different. I've never seen in my life one part being nitride or carburized. Never, ever. So yeah, it seems that both technology could place on the heat treatment business. Yeah, and in my opinion, they together or separately have some benefits, advantages, maybe some disadvantages as well. But anyway, both could be used for absolutely different part. And let me know what is the most common part when the carburizing, when the nitriding could be used.
Well, if I have to choose one type of the
only one,
one type of the detail, I would say dice.
Dice. Okay.
I can see this type of parts as a best way to use the nitriding, or maybe one of the best way to use of the nitriding to improve the lifetime of the dies.
Yeah, and
what about the carburizing side?
When I think carburizing part, I see behind my eyes, it's gear. Yeah, absolutely gear. It's the part which represents this technology.
So I think we can agree that the type of the details and the materials which is made from decided which technology could be used in every particular case.
Absolutely, yeah.
Michał, at the end I would like to thank you for the conversation.
Yeah, it was nice.
It was very interesting, and I would also would like to thank for the attendees, and I hope our conversation will be interesting for you as well.